Hello. So let's look at number 16. So this is part 2 of this question here. So we have the cylinder, someone is pulling up on it. We know that in the y direction here, it's not moving up or down, okay? So this gives us a chance to set up an F net, but we're also going to need to set up a torque net. So it says the linear motion of the person's hand during the time interval delta t is what, okay? Now, the thing that's going to be important here is that the rotation here is going to be equal to the linear motion here, or related, not exactly equal, right? So if I can find the velocity here, that will tell me the velocity here, right? Does that make sense? If I have the velocity at that most distant point, that outer rim of the cylinder, it will have the same velocity of the hand pulling up, okay? So we're going to need to set up so it says the linear acceleration, so same, if I know the acceleration, that will give me the angular acceleration will give me the linear acceleration, okay? But I'm going to need to set up both an F net and a torque net, okay? So for my F net, as we discussed in 15, we know that's 0, which means tension is equal to mg, right? The only two forces, I have tension up right here, mg down, and I know that since the F net is 0, as we discussed in 15, those two things must be equal to each other, okay? Now, I'm also going to set up a torque net. Now, it's rotating about the center, and mg always comes from the center of mass, okay? So mg is not going to have a torque. So my only torque is going to be coming from this tension, okay? Remember, tension is always Rf, so it's RT, okay? And then torque net is equal to I alpha, which equals RT, okay? And then let's just continue. I know that I is 1/2 mr squared equals, I'm going to change that lowercase r to a capital R, t, okay? Then I know one of these cancels out, so I'm left with this. Sorry, I still have this alpha here, okay? And so I have this, and I'm going to go ahead and solve for alpha, okay? So I'll have 2tm divided by r is equal to alpha, okay? And then I know that t is just equal to mg, so I'll have alpha equals 2 mg. Sorry, I just realized that I made a mistake in this step right here, right? And so I actually accidentally put m on the wrong part of that equation. Okay, so let me go ahead and change that. So I will divide by m and r and multiply by 2. So I have 2t divided by mr equals alpha, okay? And now I will plug in mg for t, okay? And so I'll have alpha equals 2mg divided by mr. The m's here are going to cancel, okay? So I have my alpha, but I want to find my r. Remember, v equals omega r, okay? I'm pretty sure that one's on your formula sheet. And this just changes to acceleration, linear acceleration, is equal to alpha r, okay? So if I have alpha, I have something like this, okay? So I'll go ahead and plug that in for my alpha here, right? So I'm going to plug that in, okay? And so I'll have a over r equals 2g over r. So r's cancel, so a is just 2g. So the correct answer for 16 is just B.